Here we go. Evelyn Gilbert, Junior High. We're all ready to go with graphing inequalities. So first we're going to start off with some vocab, and then we've got some examples for you to show in your foldable. Remember, you can watch this video as many times as you need to. You can pause, copy down those notes, and then you've got some time to listen to the explanations. Again, ask your teacher if you have any questions. Here's the vocabulary for graphing inequalities. Pause the video, take some time to write down these definitions and the examples. An inequality is a math sentence that contains a less than, greater than, less than or equal to, or greater than or equal to sign. In this example, m is less than 3. We use m as our variable, the less than symbol, and then any number, which in this case happens to be 3. So we read it like m is less than 3. You can also substitute this less than symbol right here for any of these other symbols. When they have an underline like this one, this is less than or equal to. This is greater than or equal to. That means the number, the variable, could be less than 3, or it could also be equal to 3 if it were underlined. So all numbers that are less than 3 in this case would be true for this math sentence. So it could be 2, it could be 0, it could be any negative numbers. M could be an infinite amount of values. Graphing an inequality, it's the process of locating all the numbers on the number line that would make that inequality true. So in this case, m is less than 3. We would put an open circle on the less than on the 3 because it's just less than. It's not including 3. 3 is not one of the solutions because 3 is not less than 3. It's equal to 3. So 2 is less than 3, so we need to put a dot on the 2. 1, 0, all these numbers, even all these numbers right up until the 3. So even if it's 2.999, we need to have that 2.999 included in the number line, in the solution set. So when we graph it, we put an open circle because it's just less than. If it were greater than, like one of these two, or equal to, if it has that line underneath it, then we would have a closed circle. Okay, a closed dot, because it could also be equal to that point. And then we color in all of the solutions, all of the numbers in this case that are smaller than 3. So all of these numbers get colored in. And then we darken in this part of the arrow to show that it keeps going all the way to negative infinity. A compound inequality is when you have 2 or more math inequalities. So we've got 2, like a greater than or a less than or equal to, greater than or equal to, less than or equal to. We've got 2 things going on. So in this case, here we have, let me highlight for you. Here we have our inequality, and this is a compound inequality because it's using a less than, and it's also using a less than or equal to. So we read this as negative 2 is less than k, and k is less than or equal to 3. Okay? You could also say that k is between negative 2 and 3. All right? So these are the symbols: less than, greater than, less than or equal to, greater than or equal to. And I put these little notes on the side. When you're graphing, these less than or greater than are going to be open dots. They're open circles when you're putting them on the graph. If they have the line under them, that means it could also be, the variable could also be equal to that number. So we put a closed dot when we graph those. Okay, here are the notes. We're going to do 2 types of notes today. Graph the inequalities that are already given, and then you're going to start with a graph, and we're going to come up with which inequality is described by that graph. Okay, so again, take a few minutes, pause the video, copy these down, and then I'll go through and explain each one. first one is P is greater than 9. So that means we need to have a 9 on our graph. And you can pick any of these points. Maybe I picked this one to be the 9. Also put a few other numbers on the graph. Remember, all number lines go from least to greatest, left to right. So in this case, we have P is greater than 9. So I'm going to put an open circle on the 9 because it's not underlined. It's just greater than. So now I want to color in all the numbers that are greater than 9. So I'm going to color in this 11, 10, 10 and a half, maybe 9 and a half. All these numbers get colored in. All of these that are greater than 9. I'm going to also show that the arrow is going to keep going. So I just make a little bit bigger arrow and color that in. So all these numbers get filled in right up until the 9. That shows that P, the variable, could be any of those numbers. It could be decimals, it could be fractions, anything all the way out to infinity. In the second example, we have -1 is less than m, which is less than 5. So that means m is between -1 and 5. So that means I need -1 and 5 on my graph. You can fill in any more numbers. You know, maybe you want to put in a few more lines. Okay, your number lines don't always have to count by ones. They can count by some, twos, or you can skip count if you want. In this case, I'm going to put 0. Okay, -1, 1, 2, 3, 4, and 5. This is just less than, so we're going to use open circles since neither of these inequalities is underlined. They're going to be open circles, open dots. So I put a dot on the -1, a dot on the 5. So m has to be bigger than -1. So m, it will be all of these numbers that are bigger than -1. m is also smaller than 5. So I want to color all these numbers that are smaller than 5. So when you fill in your graph, you end up coloring in all the numbers between -1 and 5. Okay, our next one is looking at another compound inequality. X is smaller than -3 or less than -3, or X is greater than 1, +1. So we've got a compound inequality. We need to have those numbers on our number line. Okay, so I put a couple other ones in there. I put 0 in there. Notice I went least to greatest. -3 is on the left of the number line because that's smaller than 0 and it's smaller than 1. Now we can go through. I said open circles because these are just less than and greater than symbols. They're not underlined, so we do not color those in. Okay, so we're going to use open circles for these. X is less than -3. That means all the numbers that are smaller than -3. Since this keeps going to -infinity, I'm going to fill in this arrow, make it a little bit bigger, to show that it's all the numbers that are smaller than -3. Since X is greater than 1, I want to show that that goes to infinity. So those are all the numbers that are greater than 1. So some examples of those could be maybe -10 could be one of the solutions. Maybe X equals 100. That would be greater than 1 as well. So you have to include all of those numbers all the way out to infinity, and this one happens to go to -infinity as well. Okay, those we didn't have any closed circles because none of those were underlined. Now in the next 3 examples, we have the graph is already done for us. Now we need to find out what is the inequality that would describe what is already graphed. So our inequality in this first example is we have our variable, and you can pick whatever letter you want. Maybe we want to use N for all of these. Okay, So in our first example here, we have the number 4 is on the graph. So we've got n and 4. And now we need to know what symbol goes in between those. What numbers are being described by all of these? So if we look at the graph, all of these numbers that are already colored in are all bigger than 4. So we're going to say n is greater than 4. Since it's an open circle, we're going to leave this as just a greater than. We do not underline it. So n is greater than 4 is our solution set. In the second example, we've got two numbers graphed here. So here's an example of one of those compound inequalities. With the compound inequality, we're going to have two things that are graphed. So in this first one, we've got, again, our variable, and maybe this time we want it to be m. Okay, so we've got m and a -3, and we also have m and a -2. Okay, so what have we got going on here? We've got all of these numbers that are smaller than -3. So we want m to be less than -3. Over on the right, we've got all these numbers that are greater than -2. So we want m to be greater than, this one is a filled in circle. This dot is colored in. So that means it could also be equal to -2. Since these two m's are separated, we do not put this compound inequality together. This is an inequality that we would separate by or. So m could either be down here, less than -3, or it would be up here, which is greater than -2. There's our compound inequality. In the third example, we've got our variable is in between two numbers. Okay, so here again it's a compound inequality, and it looks like our variable, maybe this time we'll say k, is between two numbers. In this case it's between 10 and 25. Now I need to put in those symbols. So in this case we have k is, if we look at all the numbers, it's all the numbers bigger than 10. Okay, so 10 is less than k in this case. Since it's an open circle, we're going to leave that just as a less than symbol. So you can read this backwards. K is greater than, because the alligator eats the bigger number, than 10. Okay, and then we also have up here, k is less than that 25. Since it's a closed circle, we're going to underline that 25 to show that k could also equal 25. So in this case, it's between 10 and 25. If you were to cover up this k